Ever wondered how generative AI models work? How they create new content from scratch? Or how they learn from data to generate new, unseen information? Let's delve into the depths of these intriguing models and unravel their mysteries. First up, we have generative adversarial networks, or GANs. These innovative models consist of two parts, a generator and a discriminator. The generator creates new data instances, while the discriminator evaluates them for authenticity. In other words, it determines whether each instance of data belongs to the actual training set or not. This dynamic duo works in tandem to create realistic, novel data. A real-world application of GANs can be seen in the creation of deepfakes, where GANs generate eerily realistic images and videos. Next, we have variational autoencoders, VAEs for short. These models are quite the artists, as they're all about creating new original content. VAEs are designed to encode data into a latent space and then decode it to create new data. These models are particularly good at generating complex data like images. In the pharmaceutical industry, for instance, VAEs are used to design new molecular structures for drug discovery. Moving on, we have autoregressive models. These models take a sequential approach to data generation. They generate one part of the data at a time, with each new part conditioned on the parts that were generated before it. This makes them excellent for tasks that involve sequences, such as text generation. In the world of music, for example, autoregressive models are used to create new compositions. Next in line, we have recurrent neural networks, or RNNs. These models are all about remembering. They process data sequentially, maintaining an internal state that encapsulates information about the previous steps. RNNs are often used in language modeling, such as generating human-like text based on a given input. Now let's talk about transformer-based models. These models have taken the world of natural language processing by storm. They focus on attention mechanisms, which allow the models to focus on different parts of the input sequence when generating the output. Transformer-based models are the backbone of powerful language models like GPT-3, which can generate impressively coherent and contextually relevant sentences. Next up, we have reinforcement learning for generative tasks. In these models, an agent learns to perform actions that maximize some reward. This can be applied to generative tasks, where the goal is to generate data that maximizes some measure of quality. Google's DeepMind has used reinforcement learning to train AI to play video games, effectively learning how to generate optimal actions in complex environments. Lastly, we'll discuss generative AI for data privacy, security, and governance. These models can generate synthetic data that preserve the statistical properties of the original data while protecting sensitive information. This is particularly useful in industries that handle sensitive data, like healthcare or finance. In summary, generative AI models are powerful tools that learn from data to create new, unseen information. From GANs creating realistic deepfakes, VAEs generating complex images, autoregressive models composing music, RNNs generating human-like text, transformer-based models revolutionizing language processing, reinforcement learning, optimizing actions, and generative AI protecting data privacy. These models are shaping the future, pushing the boundaries of what's possible with artificial intelligence.